For today's Knowledge Series webinar, we will be learning about the role of spatial analytics in renewable energy. So now I would like to welcome the CEO of Genesis Ray, Irfan Choudhry, to give us the introduction. Irfan?
Hello and a warm welcome to all of you. As we see that energy transition and sustainable energy are no longer just industry buzzwords that the industry is using, we see that governments, corporates, individuals alike are pledging really lofty kind of targets to adopt sustainable energy practices. And renewable energy within that we see along with cleaner energy fuels such as natural gas to be the driver for this energy transition paradigm. We are already witnessing that wind and solar have been growing at a monumental growth trajectory, and hundreds of billions of dollars are being poured into the industry for development of new projects every year. We believe that this space is going to only increase in the coming years. At Genesis Ray, we are very passionate about supporting this transition to a net zero world, and we would like to support this by developing and providing high quality data sets and toolkits where which helps in taking better decisions. And these decisions could be around project planning, project development, operations, or even project monitoring. When we started our journey around developing these products to achieve our objective, we were really looking for a partner who could support us by providing development toolkit that not only helps us in the project development phase, but also during our operation phase. GIS and spatial analytics is a very integral part of all our tools, and we wanted our partner to support by providing us a strong kind of a technology foundation for that. We also wanted our partner to support us in a seamless kind of a management of large volumes of data that is integral to development of any tools and the kind of a background processing for that. We were very fortunate in getting an opportunity from ESRI to be part of their startup ecosystem and gain an unparalleled access to all their tools and services and a lot of industry kind of guidance and exposure. Today, all our tools are built around the ESRI's architecture, and we would not have been where we are today if not for the strong support of ESRI. And this joint webinar is a case in point of that continued partnership. So through this webinar today, we would like to share our experience of how we use ESRI's tools to kind of do spatial analytics using big data within the renewable energy industry. However, before we do that, I would like to introduce Asad Ansari from ESRI India. He would be kind of giving an overview of some of the tools that ESRI has around spatial analytics. So please allow me to welcome Asad.
So my name is Asad Ansari, and I'm glad to represent over here the market leader in the field of geographic information system. That's basically GIS that we call it as abbreviation, and that's the ESRI technology, as Irfan has mentioned about, like we being the leader provider of GIS products and services. And if you look around, as I mentioned, we are the global company. And who we are and where we are present, let's understand the footprint. So we are well over present in 80 plus offices worldwide. We have presence directly with the service providers and with other technology providers across 130 plus countries. In terms of the customers, more than 0.3 million of customers we have worldwide. And let me just minimize this. Okay. And when we speak about like the other out of the box or the off the shelf solutions, so we do have a very good and supported ecosystem of the partners, which is more than 2,000 partners we have it. What they basically do is just like any technology customization development is required or data is required. So these are the partners who help us and the clients and the prospects to use our technology and provide the solutions right away out of the box. So just to give a glimpse, actually, so what exactly GIS? So this is for the people who were evaluating or who are new to it. So GIS basically stands for Geographic Information System. If I say it like in a real world, it's just like a pizza layer. So you have pizza and you keep on adding the toppings. So the same thing over here. GIS basically uses geography as a common denominator within your information system. So you must be having databases in terms of like which asset is where, or where are your distribution system, or where are your transmission lines, where is actually maximum catastrophe is happening. So there is a lot of where component that is attached to the question. And that's where actually GIS comes into picture. So you have your base map and you keep on adding the layers on the top of each other, just like pizza layers. So you have your environmental impact, you have your right of way land records, you have your towers, electric assets, your work and crews, field crews members, assets, your political boundaries of the region, or in terms of the entire resources. So this is how the GIS keeps on build up the blocks on top of each other. And that's where actually we enable the location as a common denominator within your information system. And that is called as a geographic informations right away. So why geographic information system? This is for the people, I mean, like who are new to it, and why we are evaluating it. As Irfan did mention about like the need of the hour nowadays is to get into the green energy or get into the renewable energy sources. And the biggest question that comes into mind is just like, where can I find this potential? So looking back historically, people were used to do a lot of surveys, used to do a lot of research, but nowadays data is available. All this data is available in a form of map. And we say it like map speaks 1,000 words. So that's where actually it is the need of the hour for the entire renewable energy sector to use the GIS, because you'll be able to understand where you need to have your potential sites of farming of your wind farms or your solar farms, or where you can have your geothermal locations to be built up. And there are different factors, geological, geographical factors that helps you out. So without GIS, I believe, and that's what I have seen across my experience also, that in renewable energy, without GIS, you cannot solve these problems. So the next is about like in terms of platform. That's where actually our platform comes into picture, and we have a flagship product name called ArcGIS. And as it says, like alone we can do so little, together we can do so much. And that's where actually it's not a winning point for a particular member only, but it's for the entire company. And that's where actually sharing comes into picture, or the collaboration. So it's the strength of the team is that each individual members with this particular mindset. We have an enterprise solution that we offer for the renewable energy, and that's what the renewable energy resources are being using up. So you have your ArcGIS platform in picture, which connects to your different databases, be it like imagery databases, topographic databases, or any particular database your respected organizations is working upon. And we connect to that, and we share up the information using different geo analysis. The stakeholders could be from utilities, from infrastructure, from public safety, from governance, or it could be from crucial decision makers, upper stakeholders. So entire organization and entire team is connected to the ArcGIS platform. They are performing the analysis, they are performing and computing different algorithms, and then they are mutually sharing up those pieces of information. What it helps you out with, it helps you out to be more steady, and you save a lot of time and resources in order to work in a collaborated and in a team environment. So that's where actually our ArcGIS platforms is being used widely across the verticals to help the organizations in terms of sharing optimized resources and working in a transparency environment. This also offers you apps. So I'm going to discuss about these applications also. One very important thing that we offer out for the renewable energy is like the project monitoring, real-time project monitoring, and looking up the current trend of IoT or a real-time data coming up from the fields or from particular sensors. So you need to have a dashboard. You need to have some mechanism in picture where the decision makers from the commissioning side or from the regulatory side are regularly monitoring, and if there is any deviation or if there is any particular hazard that is going to happen in the future or that has happened actually, so you can get a real-time alerts. So that is also very important. Without any load flow or any breakup of a particular power line or any particular supply, you need to have those things to be monitored. You need to have a dashboard, something like in terms of like SCADA or in terms of operation dashboards that are being connected with your project management systems at the back end, with your different databases, getting up the real-time feeds from your sensors of the field. So this entire real-time project monitoring is also a part of the package, and it helps the organization to understand the crucial aspects of running up overall business. So let's do a deep dive into ESRI technology, and let's see what we have it. So we have ArcGIS Enterprise. So that's basically comprises of a couple of projects that sits on your desktop or on your laptop. That's basically a thick client applications. These are basically your ArcMap and ArcGIS Pro, which are multi-threaded system architecture they are working upon at the back end, which speeds up your entire process. They are supported by our portal. And this particular portal is basically the ArcGIS Enterprise that we have seen, which helps you in sharing of the information with different stakeholders. It is scalable. So when I'm saying about the scalable, so you can have your multiple distributed environment also to be sitting up at the backend, so that you can speed up the process and work upon different complex algorithms also, and or on a huge data set or a voluminous data set. So alias the big data sets. In the meantime, apart from the GI server that we support, we have it image server as well, because we understand that in terms of site identification or catchment area analysis, many organizations are working on the raster dataset. Raster dataset is basically your satellite imagery dataset, and you need to have the right toolkit to process up all those data sets coming up from the satellites, downloaded from the satellites, or access in the real time. So you need to have those servers at the back end to support these analysis as well. So we do have a image server. Then we have geoanalytics servers. So this basically geoanalytics server that help you out to perform your voluminous data analysis. It's basically the big data analysis. You need to have a distributed computed environment so that it can be scalable more as per your requirement and process up the data in few minutes of time. The last one we have it is the geo event server, and this is very much required in order to connect to the field updates. That's basically your IoT based data sets coming up using sensors. So needless to say, I mean, like, we can connect to any connector that is being used up to bring the information from the sensors. So there is no challenge, there is no hindrance actually in order to connect any particular real-time feed coming up from these sensors. So we can connect it. So that's a USB of geo event server. You can connect to any particular sensors from the field, and at the backend it will process up in the server, showed up or showcased up or share up or collaborated using the portal. And finally, you have web, which can be disseminated across the stakeholders to view these analysis. The most important thing, we do have the mobile applications also, and they are very simple configurable ones, and they help you to keep yourself connected with the field crew members online and offline both, because we have seen across in the commissioning side also people who would like to understand the troubleshooting of any particular solar panel or wind panel. So you can have it done in no need of time using the mobile devices. So ArcGIS is the flagship product that we have it. It's a complete web GIS platform. We do have apps available. And when we are saying apps available, it takes a lot many resources and time to create these apps. Being the market leader from ESRI, we have offering to support different tabs for different themes. So those are only configurable, no need to customize. But if you are still interested to change the look and feel, you are more than welcome, and we provide you the APIs also to customize that as per your requirement using different development environments that we support. So one of the technology that I would like to showcase over here is about the drone mapping. So drone mapping is basically like you would like to create a digital surface model. So from the remote side, if I would like to have a survey site to be done in terms of topographic understanding, or uh, in terms of catchment area analysis, I would like to understand from the remote side that how does this site looks like, or if I want to create a 3D mesh within few minutes of time. So the first thing that comes into mind is about the drone. So let me set up the drone, just quickly have a aerial photographs to be built up. Let me take out the chip, and then you need a software to process that. So that's where actually we come into picture with our product called Drone to Map. That basically helps you out to mosaic all these photographs. So that's basically the ortho mosaics. It will mosaics your entire photographs that's been taken up by the drone. And the second output of the drone to map is the digital surface model. So it helps you out to create the elevation models for you. You can quickly understand that which areas are having a high elevation and so on. The third one, and a very unique one, that's basically a USP also. It helps you to create the point clouds and meshes too. So for example, for a rooftop analysis for solar radiation, you would like to have a quick for a building's overall survey, you would like to create a 3D mesh, so you can have it done within an hour, depending upon to the computation speed of your hardware, of your laptop or machine on which you are running this particular product. So you will be able to process all those photographs using drone to maps, and you will be able to create the 3D mesh, 3D output right away. No need to create, or no need to digitize, no need to use any other application to create the 3D textures and all those. So you would be able to create those point clouds and meshes right away. In terms of smart inspection also, for the aerial surveys, you can have it done with this particular tool's functionality of smart inspections too. Next product that we have it's basically the City Engine. City Engine is basically used for creating your 3D environment using your 2D analysis, and it helps you out in terms of planning, in terms of creating the entire 3D structures for a particular site, that how it is going to look like, where you need to place up your solar panels, what should be the direction, what if I have a building which is 21 floor, what would be the sun inclination, and how much solar radiation it would capture, how much area of the rooftop would be covered by how much dimensions of the solar panels, how many number of the solar panels will be generated to create the power out of that. So all these analysis will help you out, can be help out through this particular product that we have that's basically City Engine. So giving you an example of like how can we use it. So it's for zoning. You can have a quick understanding that which are the potential location which can help you to create or bifurcate a particular area in terms of zones, which are higher zones, which are lower zones, which are low intensity zones, and so on. Then you can have your defining of your usage also, like how much power could be generated from a particular area, what could be the parameters or the dimensions out of it. Then you can define up your rules as well. As I mentioned, like you can set up the rules like how much tower of a building should be there, so that it's not having any hindrance or any particular obstacle in between. In the near future, if there is new development is happening, that the solar panels are well exposed to the natural sunlight. You can create the reports also, because this is important to create up. Finally, by the end of the day, you would be requiring some reports. So you would like to understand how much power is being generated from what area, what are the different assets information. So you can extract the reports right away. Then you can build up your schematic designs also. It's not limited to the buildings, but other assets also. You can have your complete city planning that City Engine can help you out with. About the facade creation, lot many architectures who are working on the renewable energy side, they are very much interested to create a facade creation in terms of exterior designing. So the tool gives you or aids you with those functionalities as well. Next is about the G-Event processor, and I As I did mention about the architecture that we described, so that's basically the GeoWind processor for connecting up the real-time data set. And we support IoT technology. So any sensor that's onto the field, any stream that is coming up in a real time, it could be from buoys or in oceans, it could be your any particular device onto the field which is sensing up the temperature or water flow or any upstream, downstream kind of a reading that it is giving you out with. So we can set up the rules in GeoEvent processor, and you can have those alerts in messages, as well as you can monitor those things on a map. So it helps you out to enable your big data. It helps you out to create up your inline processing with your different uh, IoT-based sensors, and as well as geofencing as well. So if there is any particular trespassing that's happening, or if you find any particular alerts, so you need to create up the geofencing. If anything cross that fence nearby to your wind farm or solar farm, you can have those alerts right away, and you can take up your actions. So GeoEvent processor is the in the current era is the need of the hour for the renewable energy. And we do support it with the out of the box connectors available with all the sensors into the market. Next is about the Living Atlas. So it brings me to a very important thing to mention. Like, data plays a very important role, and as we say that the next century belongs to the data, which is very much required by all of the verticals. Like, you would like to understand the different topographic maps. You would like to understand different urbanization maps, zonation map. You would like to understand the different wind direction maps or different environmental maps. So that's where actually this product come into big picture, Living Atlas. So we give you out of the box the base maps. We give you the imageries. We give you the demographics as well, and our demographics are being updated for India about 90 different attributes. That's the vintage is just 4 months down the line, like October 2020 we have updated this information for entire India. The resolution of the data set is available at the taluka level, that's basically your sub district level, and we have it available in terms of Living Atlas. You can access that. You can understand the different demographics. Where are the requirement changing up? Where are the household population changing up? Where you need to focus more? When you can actually strategize and regulate your policies according to the requirement. So all those pieces of information are available as a part of the data that we have it from within your Living Atlas. So there are thousands of maps and layers that are available to be used as a plug and play. Next is about the mapping and visualization, and I would like to emphasize for the people who are evaluating it or who are using or well aware of the GIS. So we are not speaking nowadays about the bohemian kind of or era of the application of GIS. It's not simply plotting the things on a map. We are well speaking about the futuristic or the descriptive technologies also, and GIS plays a very important role. So from ESRI, we bring you out the right tools and capabilities, starting up from the smart mapping, where you can have your smart charting also with your predictive functionalities as well, or your data science tools as well. We do have the spatial temporal exploration that helps you out to understand your data in 4 dimension, not only in the 3D, but in terms of 4D as well. Then we have it like for right away from creating your applications and digitizing that in a real time, or in terms of your most fashionable manner that can be as understood by the different terminologies as well in terms of integration. So we have those mapping and visualizations, the latest one available from the ESRI product suite. But why do we need GIS for? So the biggest question is like so we need to understand why GIS is for. So that's basically the spatial analysis, and some of the use cases to understand is like where I need to put up my renewable energy farm, be it like solar, wind, geothermal, and so on. So you need to perform the spatial analysis. You need to have the, as I mentioned about the distributed technologies as well, like the forecasting data. You would like to have a prediction of the data. You would like to connect to the different algorithms. When I'm speaking about is basically the AI. You need to have a integration with Python or R and all those aspects, so you can have a better spatial analysis. So the tools are available as a part of the platform. At times, yes, you would like the coders or the data science people can use the libraries to customize that. At many times, it's available as a part of the simple plug and play tool. You need not to understand the coding at the backend, and you will be able to perform these analysis in a very effective manner. You will be able to predict the data sets information, where how the climate is going to change in future, or how is my demand is going to affect in near future depending upon various factors. So all those kind of regressions and all those kind of different kind of a techniques you can use it. So when I'm saying about the regression, it could be a polynomial degree of 4 also. So all these kind of a classifications, lidar classifications, image classifications, regression predictions, connecting with different technologies like for R or Python. So all these are available as a part of your spatial analysis tools. Real time, as I did mention about the G1 processors, so high velocity data streams you can connect to, you can monitor those feeds, and you can have your alerting also. And that I'm going to speak in my next few slide as well about the big data, because it's just like giving an example, like a Twitter feeds, a single Twitter feed. I mean, like 1 million Twitter feeds happen in a second or so. So you need to have a good computation at the backend. So for that, we have the tools available as a geoanalytics server, which helps you out to understand the entire region's voluminous data. You need to process that. You need to have an analysis of that. So you need to, so giving an example for the solar suitability, what all different parameters are there? If you are processing for an entire region or for a huge area, you can well imagine how much time it will take. So big data analysis comes into picture over here while we are working on the voluminous data, be it like coming up from the satellite imagery or aggregation to the points to a particular location. So in this particular way, we can use the parallelized analytics on vector as well as raster data both, and it helps you out to process up the data on a timely fashionable manner and give you the insightful information that you might even think of, because it's a huge ocean actually for you to do a deep insights. And it's on a multiple factors like predictions or different factors that are influencing a particular outcome. So all these part of analysis are being taken care of by our backend technology that works on distributed technology of big data. Imagery, as I did mention, like we support imageries as well. So we have powerful analysis tools, well over 100 plus tools, so which are using different, supporting different, all major sensors. So we have standard workflows also as per the industry. Like you can create up your ortho photo, you can have your ortho photo and mosaic creation, you can have your different image classification as well. And you can have your multispectral analysis also. So we do support the imagery tools, and we have the industry specific tools available. If you are towards the remote sensing side, you would like to you would like to process up the different data sets, so you can have it done using the imagery tools too. 3D, as I mentioned, you can have your 3D analysis as well. So if you are working on any other application or the software like Revit or AutoCAD product, so you can well integrate, you can well import the data set. We do support the BIM as well, so you can bring up those 3D data sets from your other applications as well. And within the system also, you can create up these 3D models too. So apps is basically the apps that we provided for the users community that help you out across your entire spectrum of the operations. It could be like your users community, it could be your internal stakeholders, that's basically the office community, and the field community as well. So we help you out with the apps that are available out of the box. These could be your bespoke solutions also, or as well as you can customize them too. And you can simply put up the data and you can perform the analysis. And we support all these apps. It's in hundred and huge in numbers that suits up different criterias, and different engineers, site engineers, functional engineers, your entire marketing or sales teams, they can use these products, and they can optimize their entire operations. App builders, it's basically the different apps, kind of app that we help you out with. So different apps will help you out to create different themes. So no need to do any kind of a programming. I'll echo again that our platform is open to get customized, but yes, more than we have had actually more than from the customers that do the you can do the uh, you can do the configurations by yourself. You just need to be a subject matter specialist. That's it, and you can simply plug and play. So we have those configurable apps. So Field GIS, basically we have the different apps for the field crew members, which helps you to connect online and offline. And just imagine if I'm working on the field, if I would like to share up the data set. So how do I share up the data set? So it's in a real time that we share up on a dashboard, and you can monitor my field investigations or the reports that I'm creating, so that you can communicate back to me that maybe I need to recheck, or maybe I need to redo surveys. So all these pieces of informations are being used using our connected ecosystem of ESRI products that helps you to connect your office staff as well as your field staff. So we have ready to use maps and apps for you. So a bit like from emergency system, from utilities, from your any particular vertical. So we do support the ready to use maps and applications. And as I mentioned, we do support development and scripting tools. So be it like Python or any runtime SDK you would like to configure, you would like to have your own app builders to be created. We support out of the box different development themes as well. You can customize and you can configure it. Moving ahead with this, I would like to share a couple of use cases that we have it and see how they work actually. So so as you can see, I believe you can see my screen right now. Irfan or anybody can confirm?
Yes,
Yeah.
Asad.
Okay, thanks. So, so this is typically an example like how do we understand GIS? So this is a problem statement to understand where I need to set up my wind farm. So for this, this is a particular story map that I'm going to present. So there are different parameters that works upon. So first of all, we understand is there is a growing awareness of the environmental decline and degradation. So due to the population, due to the different industry requirement, due to the different policies that are coming. So we need to understand like where and we need to put up the renewable energy farms. So for that, the catchment area or the site selection plays a very important role. So this is an example for UK actually. So we need to understand where are the urban areas, because that's where actually our supply is going to happen. And as you can see onto the map as well, that helps you to understand the initial data showing the urban extent of Wales. That's basically in UK, and these kind of data set will help you out to at least create a benchmark at or the building block actually where you need to start up. Second is about like you would like to have an understanding how they are actually close to the proximity to the urban population. So different tools are being used at the back end. So over here we have used a simple Euclidean distance basically. So it's basically a straight line distance between one location to another, not using the road distance, but the aerial distance actually. And we have created these hotspots with the statistical figure that says about like from yellow to blue, blue being the regions which we can actually leave out because they have a higher urban Euclidean distance. Next is about the fuzzy logic. So I mean, like people who are into these fields of computing and working on the technical side of the renewable energy. So fuzzy logic is basically a form of many valued logic in which the truth values of variables are being considered. So we are going to see which variables are being considered over here. So you can create up these thematic maps like where are your water potential, where are your accessibility to the roads, and different parameters at the back end. Next is like if I would like to understand, if I would like to have an understanding like the contamination of the water sources, because as per the criteria, I would like to avoid the contamination of the water resources during the construction and the maintenance phases. So which all areas are there, so I can have these maps also at the back end. Similarly, I can have the understanding of my different logics, which gives me a thematic map in terms of like green being the highest potential areas to those aspects, and the lower one are in the amber in color. Next, if I would like to understand, and it's very, very important to set up the wind farm is about the wind speed. So which all areas are having the wind velocity and the wind speed, actually, which all areas are there, which are having these kind of a data set, and during what period of time. So you can have maps with respect to that. And then you can have your multiple factors also, like the national parks, because you would not like to have a right of way to be created along these areas which are restricted to be used for the habitat region. So there are multiple factors. So this is just to give you an example, like how different factors are coming into picture using GIS, and finally you keep on stacking these layers and you get a finally output in terms of the potential locations. So if I give you the insightful information, so these are the areas in the blue dots that you're looking into. So these are the areas like where you can have your planned onshore wind panel to be installed, and what are the dimensions you can have it done in terms of the megawatt capacities too. So you see, this is where actually GIS helps you out to solve up these problems, to understand the site catchment area analysis and the potential of the locations. The last one I would like to cover up in terms of the solar radiation as well. We do have the tools available as a part of the tools. So this is ArcGIS Desktop, ArcGIS Pro, that we have it. So we have the tools where you are working on different elevation layers. You have your different outputs coming up, like in terms of converting your entire elevation model into a service model. And I can see quickly that which all areas are higher in elevation because of the construction that have happened over there. I can have the aspect ratio also, like which all regions are having the better aspect ratio of the solar radiation to be captured. So these solar radiation analysis tools basically helps you out to map as well as analyze the effects of sun over a geographic area for a specific time interval. So all these tools help you out with these kind of an analysis with the multiple factors. So this is basically the process data that we have it. And over here I've got the solar radiation, as you can see over here. Finally, but I would like to understand which all building footprints I would like to focus upon. So I have extracted those building footprints too. And finally, the suitable buildings. So these locations are my suitable buildings. The red in colors are the areas where I've got a higher intensity of the solar radiation that can be captured right away using this particular solar tool. With this, I would like to conclude my topic over here, and I would like to pass it to Nalini.
Thank you, Asad. For all the participants, that was Asad. Thank you for the insightful presentation on the ArcGIS and the utility for renewable energy. Kuldip, it's over to you now.
Yeah, thanks, Nalini. Okay, hi everyone. I'm Kuldip from Genesis Ray. And as for our topic today, we'll be talking about geospatial big data and its relevance in the renewable energy sector. I will be discussing about big data and how at Genesis Ray, we utilize it in the backend to perform analysis and derive meaningful insights, while my colleague Vishnu will showcase a short demo on how these insights help drive our end client applications. So first of all, we'll start off with a simple poll. Yeah, okay. So, okay, those are interesting results. So a lot of people, majority of people have not actually implemented deep learning or machine learning methods. Okay. Second is sometimes. All right. So that is interesting. So what we'll be talking about today is exactly that. We'll be talking about renewable energy sector and big data, and talking about how we at Genesis Ray apply some of these deep learning and machine learning methods to kind of accelerate and efficiently do our analysis and processes. So as we all know, more than ever, the renewable energy sector is one of the fastest growing sectors in the energy space, and is only expected to multiply this growth in the coming years. This involves a lot of planning and decision-making processes to best optimize and the outputs and make meaningful change happen. Such a forward-looking process naturally involves humongous amounts of information being generated at an ever-expanding rate. This is where the significance of geospatial big data comes in. So what exactly is big data? It involves extremely large amounts of data, which are extremely large in size and breadth. And due to the multitude of information of sources we have today, this kind of data keeps expanding at exponential rates, and thus contributing to the size and more in relatively short amounts of time. And the fact that it expands so often means that it can be highly unstructured, organized, making it extremely hard to gather any real knowledge out of it. So taking a simple example, typical camera imagery is somewhere about in the vicinity of a few megabytes. That's 10 raised to the factor of 6, i.e. 1 followed by 6 zeros. While in comparison, geospatial data like satellite imagery of large regions can range um, in the vicinity of petabytes. That is 10 raised to the factor of 19. So that's 1 followed by 19 zeros. So there you can kind of get a glimpse of the contrast and the kind of breadth of the data which we can gather while doing our geospatial analysis using big data. So satellite high quality satellite imagery would count as big data in that case. So how do we gain any meaningful insights from our data? That road leads through analytics. Using analytics, data is organized and categorized, processed and interpreted, which reveals patterns. Through this process of analytics, we are able to arrive at actionable insights, drive decision making, and solve real world problems. So next, we'll be talking about some of the core challenges with big data. So usually the big challenge, the main core challenges with big data can be described as the 4 V's of big data. So talking about the first one, it's volume, the scale of the data. So as we talked in the earlier slide, big data is extremely large in size. And for large regions of studies, this can multiply the size tremendously. This, of course, leads to storage and maintenance issues. And that is kind of a very big area where big data causes a lot of trouble. So coming on to the next point, the next V, that's variety, form of data. So there's a lot of formats of data. Data can exist in a variety of formats when talking about geospatial analysis. So there can be raster formats, vector formats, feature layers, satellite imagery, DEM data, as ESRI kind of showed in their earlier slides. And through all these data, all these formats, and due to the scale of the data, there can be inconsistencies in the configuration. So some data can be configured in a particular format, the others can be extremely varied. So all this data needs to be curated and organized so that it can later be analyzed properly. Coming on to the third V, that's velocity. That's the analysis of data flow. So new data is being generated at a very fast pace these days. This causes exponential increases in volume, and old and redundant data also keeps just increasing and increasing. This again kind of combined with the first 2 points, this again just exponentially causes more trouble with processing big data and arriving at meaningful insights. So the fourth V is veracity, the uncertainty of data, the trustworthiness of data. It's kind of described as. So data requires all your results, and data require validation, and the integrity of the results need to be maintained. This can be combined with the first 3 points. This can be extremely hard with all the volume, the velocity at which it is coming in, and all the different forms. It can be extremely hard to maintain the integrity and the validity of all the data. So coming on to the next slide, we'll talk about how at Genesis Ray Energy, we use satellite imagery to analyze and gain actionable insights. So at Genesis Ray Energy, we utilize ESRI's ArcGIS Enterprise platform for managing and analyzing our vast geospatial data sets to gain actionable insights. We primarily use high quality satellite imagery to do various kinds of analytics and processes. And as seeing from the slide, you can see there's a lot of satellite imagery data available these days, and it just keeps on increasing. So that kind of uh, leads to all that big data challenges. So we'll be talking about two specific use cases today. That's object detection for renewable energy asset extraction using ArcGIS deep learning tools and using high quality satellite imagery, and also land use classification using ArcGIS deep learning tools and satellite imagery. So coming on to the first part, it's feature extraction of renewable energy assets. So what is feature extraction? It's object detection or feature extraction is the process of identifying distinct and unique objects in imagery and correctly classifying them as such. So for example, you can identify wind turbines in a particular area. You could be identifying solar energy assets like solar panels, etc. So majority of since the renewable energy sector is constantly growing sector, and it's only kind of picking up pace now. So a lot of these assets will be kind of unmapped. So the significance of this comes in as since there are so many assets all over the globe, traditional methods of mapping like manual digitization require large amounts of human resource allocation. And for large regions, this can mean lost time and opportunities. So how do you solve this? This is where deep learning based object detection provides an effective and efficient solution to tackle the problem of mapping large number of assets. So now we'll talk about kind of the process we use using the ArcGIS platform to do feature extraction. So this is the basic flow or the basic workflow we kind of follow for doing feature extraction. It involves data, training algorithms, building models, using the models, making predictions, and then in turn using new data to kind of optimize and improve our accuracies. So the first step is training data, generating the training data. So training data is generated by, first of all, manually identifying the asset that is particularly needed to be identified. So for example, wind turbines. So if you are going to be generating training data for wind turbines, you would need to have a database of some known energy wind turbine assets that are present at particular locations. So after doing that, there are ArcGIS provides a very nifty and very easy to use deep learning tools using these geoprocessing toolboxes, which we utilize to just streamline our whole process. So the first tool over here, which kind of comes in with our whole flow very perfectly, is the export training data for deep learning. So here we kind of give it those identified and labeled wind turbines, and it generates kind of a deep learning compatible data set that is utilized in the next step. So the next step is building a deep learning model. So again, the ESRI provides a very useful and streamlined geoprocessing tool for this use. That's train deep learning models. So building a deep learning model is one of those rather complex and technically challenging aspects of this whole process. Usually, if you're doing it manually, it would require a lot of computer science and technical knowledge, and also a lot of machine learning science per se. So this tool, whereas just streamlines and makes this whole process easy by just taking out all of that complexity of the equation. And over here, we can just easily put in our input training data, which we generated in the first process on the first step, and just configure a few parameters, optimize them, and get a ready to use model. So the next step is, of course, making predictions. So once the model is generated on the second step, we input it into this third deep learning tool, and you just input the region where you need to make the predictions, and this kind of gives you the outputs. So now I'll show you some of the process samples and results which we have gathered from our analysis. So this is one of the before pictures, and after running this whole workflow, you can see all the identified wind turbines in that particular area. Similarly for this one as well. And so as for some statistics, so for let's say area of 500 square kilometers, there were a total number of turbines in the area were 721, and those were the manually identified turbines. So using this model and using all this deep learning methodology, we were able to correctly predict 699 wind turbines. So there are a few terminologies involved in deep learning, which is like true positive. That's the model has truly and predicted all the assets on the map. False positive and false negative are two types of errors which we kind of don't want, and those numbers we kind of need to keep low. So as you can see from our stats, the true positives are extremely high, 677, while the false positive and false negatives are rather low. So taking all these in accounts, we have seen accuracies achieved over 90%, which is an extremely good result. And of course, all this process can be optimized by feeding in more detailed data and larger data sets and much higher quality data. So it can, of course, improve. So coming on to the next use case, that's land use classification. So what is land use classification? Land use classification provides the distribution of various land use types present in a specific location. So this can be, for example, which areas are of a forest type, which areas are taking up a forest, which areas are built up area, urban areas or rural areas, which areas have a water content available. So all those different kinds of classifications you can get from a land use classification. So this can provide valuable insights about the current and historical land use patterns of a specific region. So over time, if you perform this analysis, you can see, as in the image, you can kind of see the change happening over time, and you can do analysis on that. You can predict patterns, historical patterns, and of course, then predict for the future as well. So what's the significance of this? Again, this provides a very detailed overview of the current land use scenario. And using this land use classification and combined with other kinds of data sets like resource mapping and asset mapping, the shareholders can actually gain valuable insights about the suitability of particular regions amongst other analysis. So again, the same issue as with the kind of feature extraction is this again takes a lot of manpower and a lot of time. And this is a rather kind of technical and nuanced area. So this can actually require a lot of resources and time. So this is again where the ArcGIS based deep learning libraries kind of come into play and help us out in streamlining this whole process. So again, so ESRI again provides very easy to use deep learning libraries and tools for using for making this analysis as well of land use. So the first step is again making the training data. So for training data, for land use analysis, we use hyperspectral image collections. These are satellite imageries with multiple bands of information. So they can have like red, green, blue, infrared, ultraviolet, etc. So again, on the tool kind of we feed the data into it, the identified points. So which pixel is of which class. So for example, if there's a pixel on a forest area, so we kind of classify it as a forest area. If there's pixel on a building, so that's a built up area. So that's how we kind of make our first training data. You feed it into this tool and it kind of converts it into very easy to use and ready to use training data for the next step, which is model building. So again, for model building, we it's actually these two tools are the same as for feature extraction. So again, we input that training data, we optimize some parameters based on our use case, and then in turn, this can give us a output model. So interpretation again, and using the last tool, we kind of get a LULC classification. So talking about the process and sample results. So this is kind of a sample result we have. It's done for the area of Gujarat, and classification through this method automates a majority of the process. It simplifies the overall process, saving resources and time. And there can be a lot of customizations and optimizations that can be done. So as you can see, you can the classes can be customized as per your needs. So as many or as little, or based on a particular area or use case. So again, we've been able to achieve accuracies above 80% using this method, and they of course can be optimized and improved further. So that's it from my side. I'll be handing it over to my colleague Vishnu now.
Thanks, Kuldip. Uh, I think he has given kind of an informative session on how do we kind of capture the big data sources out there. So in my part, I'll be majorly focusing on how we can derive insights from these big data sources out there. So before I start with my section, I would like to have a quick poll. Okay, so let's have the results. Interesting. So I think almost 95% of the people are like, okay, this is very much valuable if you have a kind of visualization aid to this big data out there. Yes, we Genesis also thought about that. And over here, we kind of plan to develop, let's say, it's a different products, basically showcasing these, visual aid. So basically what we did was we use these big data points, kind of give some visual aid to it so that it becomes very much intuitive. So we use ESRI's web application, the web app builder platform, to develop multiple products so that the users can make intuitive decisions just within the click of a button. So currently, I'll be explaining a couple of offerings that Genesis Ray has at the moment. So one is Genray Explorer. So this particular tool, one second, let me just open this. So basically Genray Explorer. So this is an energy infrastructure mapping, or let's say the visualization tool. So we have mapped almost all the energy assets. Let's say if we talk about assets, wind turbines, transmission grid, transmission towers, substations, all the, let's say, operational power plants out there, even the natural gas pipelines also. So we try to map each and every energy assets out there. So how do we make this? Of course, Kuldip was explaining the backend process of feature extraction. If you see the statistics out of, let's say, this is just for the South Asia and Southeast Asia region, where we have the access at the moment. Over there, we have actually mapped almost, let's say, 39,000 wind turbines. So just imagine how difficult that particular process is to capture that manually by a kind of a GIS expert out there, or maybe for a digitization kind of an effort. So we kind of use these kind of methodologies to reduce that complete work, at the same time, identifying and making the things much more in a faster manner. So we can see the complexity or the number of data points that we have over here. And once we visualize these in a kind of a web-based platform, you might ask me, okay, I just overlay all these assets. What can I understand from that? That's where you can, it's always good to know, let's say if you're going for any new project, or maybe any kind of analysis, you need to actually know what is currently existing in a particular area, right? So that's what this tool can actually give. It can understand, it can give a user the insights like, what is the existing landscape in a particular area, what is the typical energy mix in terms of the installed capacity, different technologies out there, competitors in the market. So all these things you can understand once we overlay all this information with the backend data for each and every asset out there. Of course, I'll be showing a quick demo in the next slides, which shows some of the features that we can derive out of this Genre Explorer application. And the other one is the Resource Pro module. So basically, for it's like a backbone, right? For any kind of RD kind of a project, maybe for a solar or a wind, without having a resource information, it doesn't make sense to do any kind of analysis. So here we we develop this resource kind of a module with almost let's say the historical data or the historical information from different sources out there. So we have a high quality wind and solar resource assessment, and that too we kind of go for a long term historical information, maybe 10 or 20 years. So the point here we need to focus here is the amount of data. If you can see the statistics out there, that these are different variables of, let's say, solar irradiation as well as the wind speed. You can just see how big each and every variables are out there. Maybe if you just take the raw values of GHI, it's close to 2 billion data points. So if you just imagine the amount of data, let's say for different layers, if you just kind of make a summation, it will almost cross 12 billions. And right now I'm just considering just for India, maybe for the 10 years time, historical information. So just imagine if we have a 30 years kind of an historical data at the same time for all these variables. So how much data points will be there? So it's always good to have that, a visualization platform so that we can actually click on any area on the map and understand what's the resource in this particular area over the time, which can actually help the users to make intuitive decisions, right? So let me just go through a couple of, let's say, a few features from the Explorer itself. You can say the name, it's near me. So basically, near me from the term itself, you will understand what is near to my existing infrastructure. Maybe I'm looking for a particular place. I can just set a particular location in the map, and I can understand which all are the nearest energy assets to my location. Or maybe it's for a new project, I can understand which is the nearest substation, or maybe for what is the nearest transmission line available. So all these analysis you can make out once we overlay all this information. So let me quickly show a video out there. So we can, I'm right now zooming. This is a Genre Explorer interface with the terrain base map view. We can see different layers out there: power generation, power transmission, natural gas also. You can see all these layers intact within a single platform. This is our South Asia application. Right, I'm kind of zooming into, let's say, the Gujarat region, where I'm trying to use this near me application or near me widget from this list of widgets that I have over here. So I'm trying to use this near me widget. I'm just trying to put a pinpoint somewhere here in this particular cluster. Maybe that might be my new project. Maybe I'm trying to put a particular project over there. You can see you can give a buffer up to 50 kilometers, and you will understand which all are the infrastructures near to my kind of a place. You can see there's a substation at 14.4 kilometers. It's a Sukhpur substation of 220 kV. And also you will understand which all are the nearest, let's say, projects out there. Maybe wind project or something, we can do that. Again, you can change the base maps, that is using the base map gallery out there, and maybe different projects, different transmission lines, all this information that you can understand just using this particular platform. That's the use of this data once we kind of put in a single kind of an intuitive platform, and the analysis that we can make out of it. Moving forward, another kind of important feature that our tool gives is, let's say, using the query tool out there. So query, again, from the name itself, you will understand we are asking a question to the tool. So, okay, so this helps in identifying, maybe locating different power plants out there. Maybe if you're interested in a particular renewable project or a particular conventional project, then we can actually drill down to that using this tool. Maybe you need to understand a competitor portfolio of a particular player. You can do that. Or maybe you are interested in a particular power project in a particular location, maybe in a sub-district. You can do all these analysis using this particular query widget. Maybe I'm just giving a quick example in a video out here. So I'm using this query widget. You can see there are a list of things that we can query on. Maybe I'm trying to find a wind project here, maybe in a state, let's say in Karnataka in India. in Karnataka state, I'm trying to look for a wind project of one of the major IPP called Renew Power out there. So I'm just typing from the exhaustive list that I have of different owners. I just got the wind Renew Power. I just click apply. So instantly what happens is you can actually visualize their assets, almost 428 wind turbines we have identified using this approach. You can just zoom in and you can actually locate geotagged, because all these information we have populated over here. So this is the insights that we get, understanding the market players out there, different analysis that you can make. And once you click on that particular asset, then there's a pop-up information which is populated from the publicly available data sources, like what is the model number, manufacturers, project, and which project it belongs to, all this information within this particular click of a button. So that's the whole point. We try to consolidate all the information, giving a visual aid. So basically big data plus the visualization aspect. One more feature, which is called infographic. Again, over here, it's pretty much straightforward. You just draw a shape on the map. You'll get an analysis out of it. For example, if you're looking for aging profile of wind assets, you can do that analysis. Maybe you might be interested in total energy by installed capacity in a particular area. You can do these analysis. So multiple other analysis, transmission line length, OEM, all this information, all the split by capacity, everything you can do. Maybe from the video, you will understand much more in a better manner. Maybe right now I'm trying to locate, let's say, wind assets, older wind assets. So there is a power generation kind of a infographic out here. You can see different options out here. I'm just trying to select maybe wind turbine aging profile, just to know, maybe I'm thinking repowering is the next big thing in India. So I'm trying to locate or pinpoint each and every older turbines. Maybe I'm looking at the Maharashtra region. So I just need to focus on Maharashtra region. So I'm zooming into that. I'm identifying there are lots of transmission lines, as well as the wind project starts to pop up. So currently, okay, I'm just gonna run that analysis of wind turbine aging profile in terms of megawatt. I'm just selecting a particular user-defined shape, maybe a rectangle at this moment. And then instantly, if after I click apply, you can see a chart showing, okay, each and every turbine, what's its corresponding age. Of course, this is coming from the backend data, the big data that we have captured at the backend for each and every asset out there. You can actually see there are different turbines, which is almost 24 years old or 25 years old. You can see the corresponding capacity, and you can see the highlighted areas on the map, so that you can actually pinpoint in these individual wind turbines out there. So this is something only this platform can offer, because we are trying to overlay that much of a big data out there, and we just use this visualization as well as the information from the data to do these kind of analysis. You can just make out just by a few clicks. Another use case, maybe you are looking for total energy by installed capacity in the same area. Maybe I'm right now selecting a different shape, maybe a polygon. So I'm just selecting the area where I'm interested in. You can do it for any place, maybe for the entire region, or maybe for the entire country. I'm just using a small area. Instantly, you'll get a result showing what is the typical mix in that area in terms of the capacity. Over here, coal is almost 3.6 gigawatt. So wind is 4.6. So I can understand, okay, wind is a major source at this particular area of interest. So you can do multiple analysis like this in this platform, just because we have overlaid that much of data and information within the same platform. And finally, a glance on our resource module, as I've mentioned. This is overlaying of, let's say, historical information of solar as well as the wind kind of a resource information. So I'm just clicking on that particular layer. You can actually see this is the wind profile using the time slider kind of a widget. Actually, it's playing for every hour. So basically we are capturing for the past 30 years the data for, let's say, the wind speed, or maybe for, of course, I'll be touching upon solar. This for wind speed, every hour you can see the wind is changing, right? And just imagine if you're doing it for the past 30 years, you'll have the best kind of analysis that you can make out if you have a very long-term kind of a historical information out there. That would be very useful for your generation calculation in the future. At the same time, as everything comes into the financial aspect, right? So we can also do that kind of analysis with real numbers from this information. Again, for solar, the same thing. From morning to the evening, you can see how the solar irradiance is changing over time in the India, let's say the South Asia region. You can see over time it's become pretty dense, and you just need to click on a particular location. You will get an instant results on the past. That's the historical information from this complete the backend data that we have captured. So that's how we derive multiple insights from these big data sources out there. So I think people must have understood how important it is to have this kind of a platform of visualization, kind of a platform to do, to get to derive a lot of intuitive insights and decision that can actually help in decision making process for the major energy players out there. So I think with that, it's the end of the session from my end. So let me ask Nalini to step in for the concluding session. Thanks.
Thank you, Vishnu and Kuldip. Thank you for showing us how Genesis Ray has been using the technology to simplify the complex raw data into more meaningful insights to derive the end user applications. Thank you everyone for staying this far into the webinar. Now we open the floor for the question and answer sessions. So as I've mentioned, you're on mute, so you can type in your questions in the Q&A box. So there was a question already that was answered by Prashant. It was asked from Naveen. Is ESRI ArcGIS platform compatible with synthetic aperture radar data? So we had Prashant answer that as SAR data can be analyzed and manipulated using ArcGIS Pro tools like Sentinel-1 and other options. So yeah, we are open for other questions, please. Also, please be reminded that there'll be a quiz at the end of this session. Okay, we have a question from Jake. What kind of data format are being used for resource layers, especially with billions or millions of data points?
Sure. So, Nalini, I think I would like to answer this question.
Yes, please.
Right. Yeah. So yes, there are many formats that we can keep these data or data layers. Of course, it's pretty much heavy. Maybe you can use in SQL database, even CSVs will do, right? At the same time, raster formats, maybe like a GRIP or NetCDF. There are different formats out there. But the point out here is, let's say if you focus on SQL or CSV, that requires a lot of intermediary steps to convert and maintain the data. It might be, let's say, of course, it'll be time consuming and it's pretty much inefficient, especially for CSV formats. Whereas we at Genesis Ray use the NetCDF files. We use, let's say, the ArcGIS platform as a features to directly use it in an efficient, let's say, directly consume that data without any tool, without any other tools interventions, right? So this allow us to use, let's say, all these data points in a much more efficient manner, and NetCDF is capable of storing, let's say, multidimensional data as well. So this entirely streamlines the whole process and makes it much faster. So yes.
Okay. Thank you, Vishnu. The next question is from one of the attendees. How can better understanding of current infrastructure using GIS can help in making better site selection process in the future?
Nalini, I'll take this one.
Yes.
So I'm sure any energy developer would agree that harnessing of renewable sources of energy is basically an amalgamation of several influencing factors like resource, landscape, elevation, land use, land governance. Now, what GIS does it helps bring us all information together as layers, saving a lot of time, energy, resources, money mostly, because it figures out the suitable criterias that one figures out by personally visiting the site one by one. Now, GIS swiftly assists in the ease of comparing, energy harness, installation perils between multiple sites, right at your fingertips within the comforts of your home. You don't have to visit that site. one by one. And to this entire ease, if you also add machine learning, if you add machine learning to this entire equation of GIS suitability for renewable energy assets, it makes the task 100 times easier. It learns from the range of different factors at which current infrastructure is already located and can find the same combinations occurring elsewhere in the landscape, giving you instant site suitability in terms of current harness policies and practices. You can readily go to these sites, and you can apply for your installations and start harness right away. Now, this can also be tweaked, given, if there is any kind of policy reform, or if there is any technological advancement that allows harnessing probably under difficult situations, under difficult terrains, where current infrastructure is not located, because of course technology is developing, right? So, better understanding of current infrastructure using GIS particularly can not only help, but make, site selection procedures very, very quick, like quicker than years together. So yeah, it's a very beneficial tool. Yeah, over to you, Nalini.
Yeah, thank you, Anishika. Prashant, would you like to take the question online?
Yeah, sure. So I have answered one question which has already asked whether RGI supports for offline field survey. So yes, we do support out of box mobile applications like Collector can support offline survey. If any organization wants to wish to have a custom application, yes, the RGS runtime SDK can help them to develop an offline field survey application. And the question also again on ESRI platform on the big data analytics side. So we provide big data analytical capability through our RGS enterprise platform. So any organization who wish to have spatial data big data analytics, in that case they can use RGS enterprise along with geo analytics server role, which helps to provide big data capability, and that can be performed either on RGS Pro or on web environment as well. The second option, if they have big data data sets in Hadoop or HDF, that can also be get registered with RGS Enterprise, and they can use Big Data Toolkit, which is a custom code that can also be utilized for big data analytics. So these are the two options from ESRI side to perform big data analytics.
Thank you, Prashant. We have another question from Aileen. What kind of infrastructure is required for performing the ML-based workflows?
Yeah, so I'll take that question. So yeah, that's a rather important consideration when taking into account machine learning based workflows. So one of the most important aspects relating to infrastructure for ML based workflows is probably the GPU. So these ML workflows are not your traditional kind of data processing analysis. So these are rather what we call parallel processing tasks. So GPUs are actually very well suited for these kinds of and are actually designed for this kind of processes. So definitely a powerful GPU with a good amount of GPU memory is actually one of the most important things there is for performing ML-based workflows. Again, it can be done through CPU-based and processing as well, but do keep in mind that will take up more time and just extend the whole process. So GPU-based workflows are extremely important and advised, since they can help you kind of streamline and fast forward the whole process and give you more time to optimize and test and validate the whole data and do the training again, perhaps. So yeah.
Thank you, Kuldip. We have one specifically for Mr. Asad from Sabrina Ashraf. Do we have options for imagery analysis? Asad?
Yes, so we do have options for imagery analysis. So we have the tool set that's a part of our image analyst. And in terms of that, you can have multiple options like orthorectification, chain detection, classification tools, like training your samples data set, as illustrated by our teammate also. So you can label your objects from deep learning. You can classify or categorize pixels into classes. You have raster functions also. Starting up right away from the georeferencing, that's very basic one, but you do have the complex as well as your iterative based raster functions as well. So all these things are available as a part of the image analyst, a tool set within the ArcGIS.
Thank you, Asad. So next one from an attendee, what are the different kinds of ML models for feature extraction and LULC?
I'll take this one as well. So there are various kinds of ML models for both feature extraction and land use classification. So choosing the right kind of a model for the particular task at hand can make a lot of difference and make your results vary and prove to be either efficient or rather time consuming with rather poor results. So choosing the proper ML model is very important. So the different kinds of models that are there for feature extraction. Now, feature extraction is an object detection based workflow. So this is kind of you have particular assets on your map and you need to identify these discrete assets. So feature extraction for this kind of a workflow, there are models like mask RCNN, single shot detector, and many more. Again, the ArcGIS tools which we had discussed in our presentation, they actually have all these different models pre-configured, and actually they are optimized for geospatial data analysis. So you can choose from the different kinds of available models and optimize based on your use case. So for land use classification, there's now land use classification. There's an important distinction that it's a pixel-based model. So each and every pixel between two images or different data sets is compared in contrast to the more discrete assets for feature extraction. So for this, there is the most one of the most popular is UNet, which we also kind of utilize in our process. There are again different parameters and configurations, like different backbones of the model that you can choose. Again, these are readily available in the ArcGIS tools, which you can kind of configure and optimize and try for your particular use case and based on your data. Yeah, thank you.
Thank you, Kuldip. Asad, another question for you. How well we can use deep learning and for classifying thematic maps?
Right. So for the thematic maps, as we understand, like it would be based upon any particular theme. So as well described by Kuldip as well, that once you're using these artificial intelligence tools, be it like machine learning or the further level of deep learning, so you need to set up a particular theme which you are actually working upon. So in terms of using the ArcGIS product, we give out, as we did mention about the image analysis, the same thing actually we do have it similar to what Kuldip has mentioned about the deep learning algorithms. So right away, starting up from the training your deep learning model. So it will help you out to learn your model using the output from the export training data set using deep learning tools. So that's number one. Then you would like to detect objects using deep learning. So that would again run a particular trained deep learning model on an input raster, basically to produce a feature class containing the objects compiling your themes actually, which you are actually interested into. So so these are different models like random forest classification. And so if you would like to, even though use machine learning as an algorithm to have a prediction on a forecasted data that how the site is going to look like, so you can have it done those two. Then you have different algorithms, be it like non-maximum suppression or compute accuracy for object detection, or generate training samples, which is very important. So you can have it done from the seed points as well. So all these part of the deep learning algorithm that we support. So this is just a glimpse. It is not exhaustive one. We do support other like EB regression or a JETIS or GI, geostatistical analysis or so on as a part of the deep learning.